And welcome to Polar Bears International's live chat for Arctic Sea Ice Day. Happy Arctic Sea Ice Day. We're super excited you're joining us to celebrate and to learn. We're very excited to have some special guests with us today and to answer some of your questions live while we learn from our experts. So we hope you'll join us for the next 20 to 30 minutes for this chat to learn about why sea ice is important and why it helps keep our planet cool. And then later today, we are very excited for the official launch of our live beluga whale camera. The cam is going to go live around 2:30 Central in the Churchill River estuary outside Churchill, Manitoba, Canada. And it's a pretty amazing view of beluga whales. So we hope you'll join us then as well. And we'll have a more formal chat about belugas and Arctic sea ice around 4 Central with Kyron McIver, who is captaining the boat up there. So again, during today's live chat, we're going to talk about why and how sea ice is important and how it helps keep our planet cool. So thanks as always to our partner, explore.org, for helping to make all of these live chats possible and bringing these amazing live camera views to us around the world. For those of you that might be spending more time at home right now, be sure to check out the Explore website because they have cameras all over the world that you can tune into to learn and be inspired and have a little bit of nature in your life. So during the live chat today, feel free to send us your questions. If you're watching on our website, you can drop them right into the chat window. And if you're watching on Facebook, you can drop them into the comments and they will get sent over to us and we'll do our best to answer those today. So we'll start by introducing ourselves. My name is KT Miller. I'm the Media and Outreach Manager for Polar Bears International, and I'm coming to you from my home in Bozeman, Montana today. And we are joined by Zach Labe and Thea today. So maybe we'll start with Zach. Could you introduce yourself?
Yeah, hi everyone. I'm currently in Colorado. I'm a researcher there, a postdoctoral researcher at Colorado State University. My background is in atmospheric sciences and climate science, and I'm really driven by a research question of trying to understand how Arctic climate change and climate variability, how that's changing, how it's affecting the Arctic, and how it's affecting other parts of the world. So I'm currently trying to put the pieces of that puzzle together, and we'll get to talk about that a little more later today.
Awesome. Thanks so much, Zach. And for those of you who like cool visuals, we're all super excited to have Zach join us today because he's an amazing communicator through visuals with Arctic sea ice and what's happening in the north. So we'll have to drop a link to your webpage and some of your amazing graphics into the comments today. Thank you. And Thea, those of you who have watched before have probably seen Thea with us. Could you introduce yourself?
Yeah, absolutely. My name is Thea Bechshoft. I am coming to you from my home in Denmark. I've been working with polar bears for the past 16 years or so doing research, and now I am a staff scientist with Polar Bears International.
Great. Thanks, Thea. So today, Arctic Sea Ice Day, we'll get into the nitty-gritty and what this has to do with polar bears, of course, given that we are Polar Bears International. But Arctic Sea Ice Day is July 15th annually. We celebrate this day. We chose July 15th based on the historic breakup of the sea ice in Hudson Bay. And nowadays, there's about a month less sea ice in the summertime in Hudson Bay than there was in the 1980s, so not that long ago. We'll get to why this is important. But first, let's just start with some basics. Zach, could you fill us in a little bit on just what is sea ice?
Yeah, so we'll just get started there. So you can think of sea ice as simply frozen seawater. You might be familiar with like an ice cube in a glass of water, but the only really difference here is that the seawater has salt in it. So therefore the sea ice has salt. We call that salinity. You might also be familiar with other parts of the frozen world, which we call the cryosphere. So anything that's frozen, so things like snow, sea ice, or also like glaciers or ice sheets, They're part of this thing called the cryosphere, and that's one aspect of climate science and earth science that we study. The one major difference here between sea ice and something like Greenland, where you talk about glaciers and ice sheets, is that sea ice is just that frozen water. So as the sea ice melts, it's not actually contributing to sea level rise like Greenland ice, which is formed on top of the land. We'll get into a bit more of how sea ice, though, can affect the climate system a bit later in the talk.
Absolutely. So yeah, frozen ocean, kind of crazy to imagine if you live, down in like Texas or California. But parts of the ocean are frozen in the north year round, and others melt every summer. So sea ice is important to polar bears. We know that. And Thea, we kind of look at sea ice and polar bears in kind of 4 ecoregions, we call it. Could you dive into that a little bit for us? What are these ecoregions, and what do they mean for polar bears? How are they different?
Yeah, so we tend to think that as long as a polar bear is on something that looks like sea ice, everything is great. But it actually, so we have polar bears all around the high Arctic, but they live in very different places. And so these different regions that we call them ecoregions, they differ with regards to when the sea ice freezes, when the sea ice breaks up, and they differ with regards to drift patterns, so how the sea ice is moving. So here in the picture, you can see the 4 regions. There's the divergent ice region, convergent ice region, archipelago, and the seasonal ice region. I'm not going to go into all of them, but for example, we have Hudson Bay, which is green, and that's part of the seasonal ice region. And so in this region, every summer, every late spring, the sea ice will disappear completely and then not come back until late fall, early winter. And that's why it's called the seasonal sea ice region. And the bears that live there, they have no choice but to be on land when there's no sea ice. Then you have, for example, the divergent sea ice region, which is the one that's, yeah. Sorry, I'm missing the picture now. You have all the sea ice that's all along the coast of Russia, for example, the divergent sea ice region, the purple one here. And here, sea ice forms along the shore, and then it retreats in the summer out towards the deep Arctic Ocean. And we're going to talk a little bit later about why maybe it's not so good to be a polar bear out over the deep ocean. So even though you're on ice still, if you follow the ice as it retreats, it's not really the same. We'll get to that later. But the whole point is that polar bears live all around the Arctic, but they have quite different, the effect of climate change is a little bit different depending on where they live. In the end, though, if there's no sea ice, there's no polar bear. But let's hope we don't get to that point.
Yeah, I think that's one of the most fascinating things about sea ice in the Arctic is that, when I first heard about sea ice, I just thought like, oh, just frozen water. There's like nothing there. It's just empty. It's flat. There's not much to it, but it's way more than that. Tia, could you expand a little bit on like sea ice and, what it actually does for the ecosystem?
Yeah, so sea ice, it is to the high Arctic as soil is to the forest. It's really where everything starts. So underneath the sea ice, you have these brine channels, these saltwater channels, and in there are tiny little algae that live. So if you flip over a piece of sea ice during spring, you'll see that there are all these algae underneath. These algae form the basis of the food chain, because then there are other tiny critters, diatoms, that are feeding off of the algae. You have copepods that are feeding off of the diatoms. The copepods are eaten by the Arctic cod, which then feed the ringed seal. And as we all know, polar bears love to eat seal, right? So the sea ice is incredibly important at the bottom of the food chain because this is where the algae lives, but it's also incredibly important at the top of the food chain because without that sea ice platform, the polar bears just wouldn't be able to catch their seal prey. So there's a lot going on around the sea ice. It's incredibly important to the whole ecosystem.
And I know we've talked about this a little bit, but Zach, maybe you could explain, like, why is the sea ice, kind of cloudy? Why doesn't it just look like an ice cube that, people watching might have in their freezer?
Right, that's a great question. This has to do with that salinity that I was talking about. It's that frozen seawater that's giving it a different color. And it's also interesting that there's different ages of sea ice. So some parts of the Arctic have sea ice that's very thin, and this is an area that melts out during the summer and then refreezes during the winter. And then you have areas that are older sea ice, and those are areas that survive during the winter and summer. So the sea ice can get thicker and thicker. And as sea ice ages, it actually is getting rid of some of that salt and putting it back into the ocean. So you can actually look at changes in the color and that cloudy, hazy color in sea ice and try to tell how old the sea ice may be within the Arctic. And as we know, with temperatures now warming, we're seeing the Arctic actually transition from an Arctic that used to have a lot thicker and older sea ice to now one that has a lot younger sea ice, and it may be more salty, therefore, too.
Interesting. Very cool. And that kind of ties back to what Thea was talking about earlier with polar bears. And as has been mentioned, polar bears need sea ice to hunt seals. They also travel on it. They need it for hunting and mating. But Thea, could you expand on what kind of sea ice polar bears prefer? Like, what is the best sea ice if you're a polar bear?
Right. So if you're a polar bear, it's best to be in what we could call rough ice, which is basically what you're seeing in the bears right here. It's broken up sea ice. It's a bit jumbled. There are some lines between the ice flows that are pressed up against each other. And that's because these areas is where you find the seals' breathing holes. It's easy for seals to keep those holes open there. They have to come up and breathe every so often. And polar bears want to be where the seals are. So that's why it's often, if you're out there, if you're in a helicopter, you're looking for polar bears, definitely look around the rough ice because that's where they're more likely to be.
So it's all about that seal habitat for polar bears. Very cool. We have a couple questions coming in, so thank you so much for sending those questions our way. If you have questions you'd like to have answered, be sure to drop them into the chat window or the comments on Facebook. So first of all, we have a question from Sharon who asks if this will be archived, and it will. So don't worry if you're at home and you happen to catch this and it sounds like maybe you want to use this in a science class this fall. All of these are archived on our website. So we'll be excited to share them with you there. And we have another question, and I think it'd be cool to hear from both of you. What does it feel like to stand on sea ice? I don't know if you maybe each have a story to share. Maybe Thea, can we start with you, and then we'll have Zach elaborate more on sea ice after.
Yeah, so I've been standing on sea ice in different situations, and usually you only want to stand on a large, stable ice flow. And if that's the case, then it's just, it just feels like standing on solid ground, really. Because if you're surrounded by enough ice, you don't really feel any waves that would show themselves otherwise. However, there was this one time last summer when we were, me and a bunch of other people, we were standing on the ice flow, and then the ship that we were on, and that was anchored in the ice right next to the ice flow, it started moving accidentally, and it pushed the ice flow. And it was a very different feeling. All of a sudden, I could feel this is a very, I know that it's a dynamic environment, but to be standing on the ice flow as it turns from static to dynamic, that was a very exciting experience.
I can only imagine. Wild. How about you, Zach? Do you have a moment or experience to share of what it feels like to be on the sea ice?
Yeah, so most of my work is behind a computer. I work with climate models, but I did have the opportunity to actually go and stand on the sea ice. And while it was a limited time there, I guess my first impressions is how quiet it is in the Arctic. And when you're there, it's so bright. I was there in May, so nearly 24-hour sunshine and lots of snow and sea ice, and it was kind of a haze in the sky. And you can't really see or find the horizon line especially on cloudy days. So it's so bright, you definitely need sunglasses. Um, when you're standing on the sea ice floe, at first you kind of feel like you're walking through a snowy field, because keep in mind, above that sea ice is a layer of snow. While the Arctic is actually a pretty dry place, it does accumulate snow on top of the ice over time. But then, as we just heard, the sea ice, it's really dynamic. So when we're on what looks like a large sea ice floe, there were people who were standing back on the ship trying to monitor the ice floe we were standing on, to look to see if it's moving or to see if it was cracking. And while we were on the ice, there were actually cracks that formed, and we had to essentially quickly evacuate the ice. So while it's peaceful and serene and quiet, it is important to keep in mind that this is an active environment and changes can happen very rapidly on top of the ice. So it took my breath away when I first saw sea ice for the first time.
Yeah, it's a pretty wild landscape. It's sort of surreal. Like, I think sometimes I've thought it sort of looks like the moon, or just feels like you're on a different planet, but really it's our planet Earth. It's the northern hemisphere. It's this beautiful, vast wilderness that's, of course, home to polar bears and all sorts of other animals. So maybe we can take a deeper dive here. And Zach, maybe you could take us into your work a little bit, and talk about, like, how do we measure sea ice? How do we know what we know about this crazy frozen ocean?
Yeah, that sounds great. So I'd like to introduce some terms that we hear about often on the news, but I'll get into what they actually are. There's something called sea ice extent. So this is something that I look at, and when you're looking at plots of changes in sea ice over time, often you're looking at this term called sea ice extent. And that essentially means that's the total area covered by ice within the Arctic. So when you're looking at this graph, you see here in the blue line, that's the extent of ice every single day in 2020. But then the yellow line is actually showing what the average amount of sea ice in the Arctic should be. So you can see, for instance, in 2020, we're actually below average every single day so far this year. And now, moving into early July, we're actually the lowest ever recorded. And we get these measurements, when I say ever recorded, we're getting these observations from satellites. So essentially, the satellite is going over the Arctic, and it's actually receiving microwave radiation. So essentially, that's being emitted in the satellites, and then scientists can interpret that information to tell us how much total ice is within the Arctic. And then one other word I want to talk about is the thickness of ice, or sea ice volume. So that essentially is what it means. That's the thickness of the ice. And this is something that's actually much more challenging to measure. Whereas the satellites flying over the Arctic, it can easily see the total area of the ice. But it's much more difficult to actually get the satellite to tell us how thick that is, because that isn't necessarily straightforward or obvious to the satellite that's measuring. So we can use a lot of different tools to try to get at what the volume or the thickness of ice is. And what you're looking at here is, again, the daily amount of sea ice volume. That was what was in the yellow line. And then you're looking at every single year since 1979 of what the sea ice volume was in the past. So you can see that, again, here in 2020, we are much below average for sea ice. And you can see in the darker blues, like in the 1980s and 1990s, there was a significantly more amount of sea ice within the Arctic. It was both larger in area and it was thicker.
Very cool. Sea ice is so complex and dynamic, and it's just wild to think about, certain areas where it's frozen for years and it gets thicker and thicker, and then other places where it just freezes in the winter and melts in the summer. So I always hear this word, Zach, in the news. And I always I think I have a pretty good understanding, but I would love to hear your take on this sort of buzzword in climate science, Arctic amplification. Could you help me unpack that term a little bit?
Yeah, that's a great question. Arctic amplification is essentially means that the Arctic is warming a lot faster than anywhere else on the planet. So when you hear, for instance, 2019 was the second warmest year on record for the globe, Arctic amplification is telling us that that rate of change, or the speed of warming in the Arctic, is more than 2 or 3 times faster than it is when you average across the whole planet. And Arctic amplification is really important. We can see here in this graph that certain areas of the Arctic are warming much faster than the other areas. So some polar bear habitats, for instance, can be more susceptible to this sort of regional warming. And we're seeing this faster warming in the Arctic because of different things in the Earth's system. We call that a positive feedback. Essentially, it means an acceleration. In the Arctic, one of the positive feedbacks we are most familiar with is essentially called the albedo feedback. That means the Arctic is this bright white surface. So when there's incoming solar radiation, the bright white surface can reflect some of that radiation back out into space. But as Earth's climate is warming due to greenhouse gas emissions, that warming is starting to melt the sea ice. And now you have areas of the Arctic Ocean that are open ocean. So instead of being a bright white frozen surface, they're now dark. So that incoming sunlight, instead of being reflected back into space, it's now being absorbed into the Arctic Ocean and then being emitted into the atmosphere. This causes that acceleration of warming in the Arctic. It's this feedback. So more warming, less sea ice, then there's more warming. So it just continues to build and build. And that is Arctic amplification.
That was a fabulous explanation. Thank you so much. And for those of you who maybe are still trying to wrap your head around that, you could almost think of it like wearing a white shirt on a hot summer day versus wearing a black shirt, which is going to make you warmer, which is going to keep you cooler. So very neat. We got another question that came in, and I think this one is perfect for you, Thea. The question is, how do polar bears navigate on the sea ice without any landmarks?
Mm-hmm. That's a really good question, and it's something we still are trying to figure out. Either, these are the theories, they probably, polar bears have an amazing sense of smell. So probably they can smell things out there that we can't, like how far away, a special place is, how far away are the seals, how far away is the land, things like that. They may also, during the polar night, where you have the moon and the stars most of the time, they may be able to navigate by the stars. They may be able to use Earth's magnetic field, just like birds can, but we don't actually know just yet.
Well, that's kind of fun. So maybe if we have any students watching, if you might want to become a scientist someday, maybe that's a question that you might want to try to answer. There's always new things to learn and discover for curious minds. So
definitely.
I have another question, Zach. I kind of want to take one more deep dive here since we have this sea ice expert with us, which is such a special treat. So as, somebody who might be reading the news or seeing things coming up on my feed, I also often see, this is the lowest year on record, or this is the 10th lowest year on record, things like that. So could you kind of unpack that for us a little? Like, what are the impacts of these record lows and near record lows when we hear about Arctic sea ice?
Yeah, that's a great question too. So what we're seeing are long-term trends. So it's very often in the news you'll hear that, oh, 2018 was so-and-so lowest year on record for the amount of sea ice. And as a climate scientist, I'm really interested in how unusual is that event? Is that record low just by chance? Or can we step back and look at all of the data points and do we see a trend? And that's what I'm interested in. So when we look at sea ice changes, this record low event is not just by chance or random. We can see that every single year we're seeing the long-term trends of declines in sea ice thickness and the total area of it. So because of weather, and we know that every town, their weather changes rapidly from year to year. That's very similar in the Arctic. Every year there's always changes. So while we might not see a record low sea ice every single year, we can step back and look at all of the years together and see that in general, there is this pattern of declining sea ice. This graph you can see here, each line is showing a different year in the amount of sea ice along Siberia. And you can see that the darker colors are much higher up, indicating that there's more sea ice. But then you can see that there's lighter colors, like in the 2000s and most recently, and that's indicating that although the lines, go back and forth, so they're very noisy, we can see that over time they're slowly getting lower and lower in the graph, indicating that there's less and less sea ice. And this year is very unique. Here in 2020, we're actually seeing the lowest amount of sea ice on record in Siberia. And scientists are trying to understand how that fits into this long-term trend.
Fascinating. Thank you so much for helping us unpack that. I think if I've learned anything working with Polar Bears International, it's just that there's a lot of complexity and nuance to all this stuff, and there's always something new to learn and ways to better understand what's happening in the Arctic and with research. So Thea, maybe we can tie this back to people a little bit. Like, why does this matter to people who live in the north and people who live, where you and I live in Denmark or Montana, or even down in Texas, South America, the rest of the world?
So it makes sense to most people that having a healthy sea ice environment is really important to people who live in the high Arctic. They use the sea ice for traveling and for hunting. And also just transportation between settlements, between cities. So really important. It's also important for a lot of the traditional ways of living. For example, a lot of people have, what do you call it? The cellars, the ice cellars, where they basically dig a hole down through the permafrost and then they store all the meat that they harvest during the year. They store that in that ice cellar. And, now that the climate is changing, this just isn't an option in many places anymore. So it really has a huge effect in many different ways for people in the high Arctic. However, like Zach was saying before, it really also concerns the rest of us, no matter how far away from the high Arctic that we live, because the sea ice is, it's working as this global air conditioner, we could call it, because this enormous white surface, it reflects the sun's rays. So it helps us keep the temperature of the Earth down. And when we don't have that reflecting surface, the ocean temperature increases. And that, of course, affects the high Arctic, but it also affects the rest of us because the high Arctic, the ocean, it distributes heat and moisture and nutrients throughout. Like it doesn't matter where you live. If you're on planet Earth, you're affected by what goes on up in the high Arctic because of, if the moisture content of the air, if the heat in the area that you're living, if that is not optimal, if that's off kilter, then, disruptions to the system, it has a large number of effects. For example, more droughts, heavier rainfall, a long list of uncomfortable things to experience.
Mm-hmm. Yeah, the Arctic is really kind of like our air conditioner or our refrigerator around the world. We all, need that Arctic sea ice to keep the planet cool, to keep our climate healthy and in check. So thank you, Thea. We have some questions coming in, so maybe we'll take a few of these. The first one, I'd love to hear from you, Zach. Somebody, I think in the chat window on our website, would like to know why, what made you interested in studying sea ice of all things?
Yeah, that's a great question. I'm originally from Pennsylvania, which is certainly far from the Arctic, but I've always really been interested in weather, storms, even sunny days. And growing up, I was always super fascinated by the weather. And I went to college to study meteorology and weather. And then in graduate school, I was interested in how can we sort of predict the weather using conditions, particularly in the Arctic and North Atlantic. And I saw this as I learned more about the Arctic and understanding how it influences global weather. I realized that this Arctic is a region that's changing so quickly. I could be studying one area of the Arctic, the sea ice, and trying to understand how it influences the weather. And then the next year, that area would be melted. So I just thought, wow, this area is changing so fast. It has global implications. It affects everyone. And there's people that live in the Arctic, and it's impacting these changes to them today. And I always try to emphasize that. So I've been driven in how can we better understand this really remote area? We don't have a lot of observations because it isn't a frozen ocean. So how can we better understand this rapidly changing region, and how will it impact people all around the world?
Very cool. That's neat, kind of how you followed your curiosity, beginning with weather and sort of following that into Arctic and climate. And Thea, I think it could be fun, for you, it's not so much sea ice, but polar bears. Like how did you get interested in studying polar bears?
I'll make a very long story a little bit shorter. But I was living in Svalbard, this group of islands that's between Norway and the North Pole, and studying at the university center there. And I was looking for a good project to do my master's on. And all of a sudden, a friend of mine said, hey, there's this professor in Oslo, in mainland Norway. He has 700 polar bear skulls that he would like someone to study. And I find animal skulls really fascinating. I love the high Arctic. I'd already seen polar bears in the wild because I was living there in the high Arctic. And so I jumped on that and did my master's on that. And then, yeah, that just led to even more polar bears in other places in my career following that.
So did you actually physically look at 700 polar bear skulls?
I did. 700 polar bear skulls, not just once for each skull, but at least 4 times for each of them.
Wow.
It was a huge data set. Yeah.
That's pretty cool. We've got a couple other questions that have come in, and I don't know if we're going to be able to answer this one. We might have a stump the scientist on this one, but we'll give it a try. Zach, you might know. So Liliana asks, do you think the ozone hole has closed a little bit? Is there a possibility of a better quality of life for polar bears and sea ice, let's say, in the future? I don't know if you know much about the ozone and feel comfortable speaking to that at all.
I can answer it a little bit. I don't know influences with polar bears, but I can talk briefly about ozone and weather in Arctic. So this year something in wintertime that forms is something called a polar vortex. And it's something we hear often in the news, but it's actually like a storm system, or we call it in meteorology a low pressure system that's really high in the atmosphere. We call that the stratosphere. And we see that when the polar vortex is really powerful, it can affect the ozone hole. And the ozone hole in the Arctic is much smaller than the Antarctic one. And that's the one we're most familiar with the ozone layer and things. So this past winter, we had a very strong polar vortex, which caused this small Arctic ozone hole. And I'm not an expert in atmospheric chemistry and ozone, but my understanding is that this Arctic ozone layer or small hole that formed this winter does not significantly affect us here, life like it does in the southern hemisphere. But it's an interesting science question of how the polar vortex and the ozone hole and how that's all connected to the Arctic, and whether or not the polar vortex can affect sea ice is still an interesting question too.
Sounds like another question for our aspiring scientists out there to take a deep dive into if you're also curious about weather and climate. Yeah, and we had another question that dovetails with the polar bear part, which maybe Tia can help us with. But essentially, Liliana asked, and then T also asked if there's any good news for polar bears, for people that are really concerned about their fate and their future.
Well, I mean, I personally think the best news that we have for polar bears is that we have the power to protect them. It solely depends on our actions and mainly who we vote for. So you have the power to change all of this and to make these webcasts very different. So, vote with the climate in mind. Vote for people who are willing to make drastic changes to the kind of energy that we're using to power our homes and, well, everything that we do. If we could move towards using renewable sources like solar and energy, that would be amazing. So I feel like that's the best news for polar bears, because by now it's not about stopping climate change, because that doesn't really happen. There's a lot of inertia in the system, but we can absolutely make sure that the scenario that we're heading into is so much better for the sea ice, for polar bears, and for humans around the globe.
That's great. And Zach, I don't know if you have anything specific you want to add, kind of what gives you hope, or what people can do that care about the Arctic, care about sea ice, and care about polar bears.
Yeah, I'll add one more point in, and we've mentioned a lot that this sea ice is just frozen seawater. So if climate model projections show, that the ice may dwindle or possibly disappear in the summertime later this century, what's great about, we have this opportunity to reduce greenhouse gas emissions means that we have the possibility to reduce that chance that sea ice disappears. If the Arctic stays cold enough during the winter, it's going to grow that ice. So we really have the opportunity now to prevent an ice-free Arctic. There is still that chance. And I think that leaves us with a lot of hope going forward the next couple decades.
Yeah, that's an excellent point. We can turn this around. It is possible. There is hope. And Arctic sea ice can return if we can keep cold temperatures in the north. So, well, with that, I think we might wrap it up for the day. It's been super fun to chat with everyone for Arctic Sea Ice Day. I hope that you learned a little bit. It's been such a treat to have Zach with us as an expert on sea ice, and have Thea with us as always, one of our polar bear experts who, I don't know if we've stumped you yet, Thea. But thank you so much to all of our viewers. Yeah, we can usually at least, come up with some kind of an explanation or explain why we don't know, right? Yeah. But yeah, thank you all for joining us for Arctic Sea Ice Day today. We hope you spread the word with your friends and share this special day with your community. One of the biggest things we can do is keep talking about climate change and keep this important issue for polar bears and for all of us kind of at the top of our agenda in our communities, with our friends, in the media. Be sure to tune in to the Beluga Cam today at 2:30 Central and throughout the summer. The schedule is posted on explore.org for high tide, when the boat will be out. And we'll be having a little bit more formal weekly live chats to learn about beluga whales, about sea ice, about polar bears, and how that whole ecosystem is interconnected. If you're spending more time than usual at home, or if you're a teacher preparing for the fall, be sure to check out the Education Center on our website. We've got lots of information about polar bears and protecting the habitats that people and polar bears depend on, including curriculum and archives of all of our live webcasts. As always, we want to thank explore.org, our partner. Be sure to follow your curiosity around the globe on their website via their live cams, whether you want to learn or just relax a little bit. The Beluga Cam is especially great for that. And thank you again to our sponsors, to Zach and Thea for joining us. And thank you to all of you viewers out there for supporting sea ice and polar bears. So we'll catch you later this afternoon on the Beluga Cam, and thank you. Happy Arctic Sea Ice Day.
We celebrate Arctic Sea Ice Day to raise awareness about how amazing Arctic sea ice is, not only for polar bears, but for all the animals in the Arctic that depend on it for survival, and for humans.
Polar bears need sea ice as a platform to hunt their main prey, ringed seals.
Sea ice is to the Arctic Ocean as soil is to the forest. It really forms the base of the food chain. Algae grows in the sea ice, which feeds diatoms, which feed copepods, which feed fish, which feed seals, which feed polar bears. And polar bears rely on the sea ice as a platform to hunt those seals. They could not eat their dinner if it wasn't for sea ice. As we all know, when we're outside in the summer having a drink, when it heats up, ice melts. And that's what's happening in the Arctic. We've simply trapped too much heat in our atmosphere and ocean, and sea ice is declining because of this. As we lose sea ice, we're losing vital parts of this Arctic ecosystem, which will have ramifications across the world. There are lots of things that you can do to help protect sea ice and polar bears.
You can do your part on Arctic Sea Ice Day to act for our climate.
Check out what's going on in your community. I bet Google knows something. You can see what's already happening with solar and wind power near you, and if there are other ways that you can reduce your fossil fuel usage with the people around you.
Directly support or advocate for renewable energy in your state, province, or country.
Also, make sure that your friends and family know what you're doing. Spread the word on social media about what you find out and what you're doing to lower your fossil fuel consumption. Sea ice is super cool, it's really important, and no matter where you live on the earth, it affects you.
Thanks for celebrating Arctic Sea Ice Day with us.
July 15th is Arctic Sea Ice Day. We celebrate Arctic Sea Ice Day to raise awareness about how amazing Arctic sea ice is, not only for polar bears, but for all the animals in the Arctic that depend on it for survival, and for humans.
Polar bears need sea ice as a platform to hunt their main prey, ringed seals.
Sea ice is to the Arctic Ocean as soil is to the forest. It really forms the base of the food chain. Algae grows